So in this lesson, we're going to look at exponents that are fractions. First thing I want you to write in your notes is this word fraction. We know that a rational number is a fraction. We studied that in our last unit. So if we have a rational exponent, that means that exponent is a fraction. So the first thing I want to look at right here is a, so any base to the power of 1 over n. So we've seen something like that before. That is just going to be called the nth root of a. So an example that you've seen before is like 4 to the 1/2 power. That is the square root of 4, which is 2. Okay, so what if we have a fraction like this where the top number is not 1? What happens? That's okay. So if we have that, we can write it as two different things. We can either write that as the nth root of a to the power of m, or this is the way I like to write it, the nth root of a and then the power of m. I think if we think about it either of those two ways, we're in a good spot. So we have two different forms here. One is called radical form. This is what we call radical form. And then we're going to put things into exponential form. That's like this. And so we're going to do a couple things, vice versa. So we'll go from radical form and to exponential form, and then from exponential form to radical form. All right, so a little bit of practice for us here. The fourth root of x can be rewritten as x to the 1/4 power. Final, love it. Okay, so the fifth root of x squared, we're just practicing, can be rewritten as x to the, so one thing Mr. Parker talked about that I like, he says top is the power, bottom is the root. Top is the power, bottom is the root. So he kind of just chants that probably by himself. Top is the power, bottom is the root. Top is the power, bottom is the root. Little catchy little saying here, but what he really means is the top of the fraction, because we're talking about rational exponents. The top of the fraction is the power, and the bottom of the fraction is the root. Okay, so something to think about. Nice little way to try to remember that. Top is the power, bottom is the root. So this is the second root of x to the first, which we can simplify a lot there. Like x to the first we don't need to write, and the square root we simplify to this. Final here. It's a common root, so common that we don't actually write the index. Top is the power, bottom is the root. So we have a couple choices here. We can write this as the third root of x squared, or we can write this as the third root of x, all quantity squared. You do have two choices here. Either one of those works. So in these examples here, they want us to use fractional exponents to write these expressions. So we have an expression here. This is we're taking the fourth root of the radicand here. So our first step is to rewrite this using a fractional exponent. So we're going to rewrite this as 16 x to the 8th, y to the 10th, all to the top is the power, bottom is root, so to the 1/4 power. All right, and in doing that, what we're going to do now is we're going to separate these pieces. We have three pieces, 2 powers, and then 16 on the inside. So we're going to separate these each to the power of 1/4. So it's going to be 16 to the 1/4. And we'll use some parentheses here. X to the 8th to the 1/4. And then another set of parentheses, y to the 10th to the 1/4. Okay, so in simplifying some of these, 16 to the 1/4 is the fourth root. So this particular one right here is the fourth root of 16. What times what times what times what? And I believe that's 2 times 2 times 2 times 2. And then x to the 8th to the 1/4. Well, what we do here is we multiply these fractions. So this is x to the 8/4, which simplifies to be x squared. We'll do that in a moment. And this is y to the 10/4. All right. So wrapping all this up here, we have this first thing, the fourth root of 16, which is 2. X to the 8/4, which is x squared. and then y to the 10/4. So y to the 10/4 can be simplified, that fraction, but it's still a fractional exponent. It's going to be 5/2. And there we go. The expression is equivalent to this one, written with fractional exponents. Let's practice some more. Take the base, and we rewrite the root as a power, 1/3 power. We then take each of these numbers and use the exponent 1/3. So think about it this way, we're multiplying, so it's 6 times 1/3. And so one way that you might want to think about this is, this has like a 6/1, 9/1. So when we multiply 6 and 1, 1 and 3. That's why it's 6/3 and 9/3. Okay, so simplify here a little bit. What times what times what? This is a perfect cube. It's -5. X is going to be x to the 9th to the 3rd root is a perfect cube, x to the 3rd, and this is going to be y squared. So our fraction rules for simplifying apply here. If we can simplify, we will, otherwise we'll leave them as a fractional exponent. So more practice, speed up if you need to. If you're good to go, you can just keep going. So in this example here, we have a square root. So we're going to take 100, x to the 9th, y to the 7th, to the 1/2 power. So 100 to the 1/2, x to the 9/2. I'm multiplying y to the 7/2. Multiplying 7 and 1/2, 9 and 1/2. Now I'm going to simplify. 10 is 100 to the 1/2. This cannot be simplified, so I'm going to leave this as a fractional exponent, and the same thing here. We're just practicing going back and forth here. So in this case, it's okay to have fractional exponents. One more for you here. So we got -100, x to the 4th, y to the 13th, all to the 1/2 power. -100 to the 1/2 power, x to the 4/2 power, y to the 13/2 power. We're multiplying the 1/2 by each of those. And right out of the gates here. So the exciting thing in this problem is right here, negative square root of 100 is square root of -100, which is in the real number system is not possible. But since we found that there's an imaginary solution to this, the square root of 100 is 10, and the square root of -1 is I. So the square root of -100 is 10i. And then we have this x to the 4/2, which is x squared, and then y to the 13/2. Final here. Okay? Everything here. All right, so here what we're going to do here is we're going to write equivalent expressions with multiplication. Basically think about simplifying using fractional exponents. We're going to get rid of our roots here. So we're going to simplify each of these, and then we're going to use our exponent properties. So in this first example right here, it is 2 to the 5, 6. Top is power, bottom is root. 2 to the 5, 6, which now I'm going to think about my properties here. Same base. We're going to add exponents. All right, so this is 2 to the 10 6, which if I can simplify that fraction, let's do it. We don't want to leave it as a decimal, leave it as a fractional exponent. 5/3. Final. Let's try some more here. Each of these is slightly different. The first one is going to be 7 to the 1/2. Top is power, bottom is root. 7 to the 6/5. Now, this is a great example to look at. Well, what happens? How do we add fractions? Same rules apply. We have to create a common denominator. So let's use 10. I think 10 is a great common denominator here. So this is going to be 5/10, and this next one is going to be 12/10. Now this is going to give me 17 over 10, which is it. That's simplified. Last but not least here, let's just show you slightly different. 6 to the 5 6, 6 to the 1 6. Let's add our exponents here. 6 to the 6 over 6, which is 6 to the 1, which is, voila, 6. Now that one I'm going to heart because I love that one. All right, last thing we want to do is we want to practice writing expressions that have exponents with fractions in them as radicals. So we're going to practice putting them in radical form and then simplifying where we can. So we, again, talk about top and bottom. So top is the power, bottom is the root. I like to do the root first. So you can do whatever you want, but I like to do the root first. See if I can simplify. What times what times what? That is a perfect cube. Now I can simplify some more, heart it, or box it. Now if you do it the other way, you just get a really large number because you square first. You square negative 125 and then take the third root. To me, it's easier to take the root of a smaller number. I'm just used to that. Okay, so same idea here, but now I have a fraction as a base. That's okay. That just means that I'm going to multiply each of these exponents. Think about that as a 1 by 1/3. All right, so that's x to the 3 over 1, which is 3 over 3, over 27 to the 1/3 times 1. Okay? What do we got here? We got x to the first, which is just x, and then 27 to the 1/3. That is the third root of 27. Final, x over 3. Whew, satisfying. Okay, so here, number 3, we have a base that's with an exponent and then a fractional exponent on the outside. That's okay. Think of this as a fraction. So we just use our fractional rules here. Multiply, simplify, and that's it. We actually don't have any radical at all because the 2 went away. It went into 6 3 times. Okay, here, word to the wise, simplify. Inside first. Now, that's when you can. So in this example right here, I would simplify x to the 5th over x. One of those crosses out, and that's a 4. So this is x to the 4th to the 1/4 power. Now I'm going to multiply. So this is x to the 4 over 4, which is x to the 1st, which is just x. And that's it. Good luck.